Assalamu alaikum. Here we are back after the gap of 2 weeks. Now in this video we will going to solve question 1 from the paper of March 2023, paper 1 variant 2. This question is related to the same chapter, same topic, quadratics. In the previous three parts we discussed these three questions. Now here is fourth part related to the quadratics. So here, let's read the question. What is the question? Words. Let's go. A line has equation y is equal to 3x minus 2k and a curve has equation y is equal to x square minus kx plus 2 where k is a constant. Then it is saying we have to show that the line and curve meet for all values of k. Okay, so here we will we will equate both the equations. Let's see how. We will do this. 3x minus 2k is equal to x square minus kx plus 2. Let's write it here. X square, let me silent it, minus kx and minus 3x minus 3x. We took this 3 to the right hand side, and then plus 2 and plus 2k. The sign of negative 2k got changed after going towards right. Plus 2k is equal to 0. Now here we can use a discriminant to show a is 1 here, b is the values with the variable x, negative k and negative 3, and c is the values without the variable, means 2 plus 2k. Now here we have to apply discriminant. What is the discriminant? Discriminant is b square minus 4ac. Just we have to put these values into the discriminant and we will get we can show that it meet at all values of k. We will insert minus k and minus 3 whole square and then minus 4 1 getting multiplied and 2 plus 2k. Here we solve it further algebraically, and if we expand it, it becomes k square plus 6k and then plus 9, and here it become minus 8 and minus 8k. Let's arrange it properly. K square minus 2k and 9 minus 8 is plus 1. If we do middle term here, so it will become k minus 1 whole square. It will be a factor, and we are sure that if we insert here any value like insert 0, if we insert 0, so it will become positive 1. 0 minus 1 will remain negative 1 and negative 1 whole square will become positive 1. If we insert 2 here, so it will become 2 minus 1. 2 minus 1 is equal to 1, then 1 square is again 1. If we insert 1 here, so 1 minus 1 is 0, so it will become 0. If we insert negative 5 here, so it will become negative 5 and negative 1, it become negative 6, and whole square means it will become 36. So it will always become positive value. So here we can show that k minus 1 whole square, anything which is getting square will always be positive. And when the discriminant is greater than 0, it meet at not it meet at 2 points, but here it is saying that it meet at all values of k. So we can see that when we are inserting 1 we are getting 0, so we have to place it can be equal to 0. We can't ignore 0, it can be equal to 0. And if we learn discriminant, if we go through the notes, so we can see that when the word meet is written, it will always be greater than equal to 0. So we will write the final statement. Hence it will meet at all values of k. So that's our statement, final statement, which is for 1 mark. Now let's have a look on our solution. There we equated both equations, and through we had formed a equation on which we can apply discriminant. After applying discriminant, we got a quadratic equation again, and we did middle term here and factorized it. It become k minus 1 whole square. So anything which is squared, it can be 0 and it can be greater than 0. It is a rule. It can't be negative, but it can be 0. If we substitute the same number here, like here is negative 1, k minus 1, so we can substitute positive here, positive 1, so it will become 0 and 0 whole square will be 0. So we can get 0 here, so it is equal to greater than equal to 0. Hence it will meet at all values of k. Thank you. Inshallah we will meet in the next video soon.